Um, so we're going to change gears a little bit and move kind of east and south from San Solomon Springs, and talk about groundwater, but how it affects surface water. And this is going to evolve into some international issues and some interesting hydrogeology and surface hydrology. One of the things I failed to mention earlier in my other talk is that we have a new research institute at Sul Ross. It's the Meadows Research Institute for West Texas Water. We got some funding from the Meadows Foundation. We are sort of linked with the Meadows Center for Water and the Environment in San Marcos, Robert Mace and others over there, and Andy Sansom. So we're all kind of part of the same group now. And we're very excited about that. So groundwater contributions to the Rio Grande and the Rio Grande Wild and Scenic. So first, some geography here. We see the map there. It's got kind of Brewster County, the Big Bend, the brown areas that are south here are protected areas in Mexico, and we have a good collaborative relationship with CONAMP that monitors those. It's all the river, and there's property on both sides. And for reference, as I make this presentation, to know where things are that I might talk about, Mariscal Canyon in south part of Big Bend National Park is there. San Vicente Canyon is there. Boquillas Canyon is up here. Rio Grande Village is right in there. Black Gap Wildlife Management Area is here. The lower canyons in general are in this vicinity. And then at the bottom would be Foster's Weir in that location. That will be one of the locations I'll mention. The definition of wild and scenic, Rio Grande wild and scenic, first to be wild and scenic, you have to be wild and scenic. You have to have some remarkable values, and our Rio Grande has that. The designation actually begins over here at this two-state line, Chihuahua and Coahuila in Mexico, and it goes 100 and I forget the number of miles, 196 miles to Terrell Valverde County line. So that's a federal designation. Some of it's in the national park, a lot of it is not. So it is in private property anywhere below, except for Black Gap, yet it is still under that federal designation. The lower canyons that I refer to really are from Black Gap vicinity down to south of Sanderson, or if you know where Dryden is on Highway 90, that the lower canyons technically are about 82 miles from La Linda to south of Dryden. And that will be the main focus of my talk, even though I will get into some larger international issues. It truly is wild and scenic. The only reasonable way to get to any part of this is by going downriver in one of those. There are really not any roads. There's a few, but that gets you up at the top and it's down in the canyon, and those roads are not very good. General Land Office just bought the Brewster Ranch. They own some of the river access on the north side. Curious to see how that might come about. But to do a trip, this is usually 7 days. You're out there from Black Gap, La Linda, whatever. You're doing science, but you're going to see something like this every day. So it's not only getting down there, figuring out how to get your science downriver in a canoe. And we have a lot of equipment for measuring stream discharge and water chemistry and sampling and stuff. But you also have to get those canoes through some obstacles. This is Upper Madison Rapid. At low water, it looks like this. You can imagine what that's like in higher water. It's pretty sporty, I can say. And I think Pat out there would agree with me. So anyway, wild and scenic is very descriptive of this. If it's the thing you like I do, and a couple of my students, I don't know, I saw Tina here. I have a grad student who's been down here 3 times with me. She's done 3 full trips. If it's what you like, it's cool. It's really, really a wonderful experience. But what I don't do is take whole classes, because I know some people don't want to do that, and I don't want them out there. So this is kind of for the people who want to do it. It's very, very rewarding. This location is international. Like I said, the Rio Grande starts way up here in Colorado, and then it flows down into Big Bend. what's really more important for us is the conchos comes out of Mexico there. Really, that significance is related to an interstate compact, the Rio Grande compact between Colorado, New Mexico, and Texas, basically rules out much water coming in from upstream. So basically 100% of the Rio Grande is appropriated to use below Fort Quitman, which is up here right below El Paso. So we really, even historically before that, but today, there's very little water coming into Big Bend from upstream on the Rio Grande. So really we're reliant on the Rio Conchos that comes out of Mexico. And there's a treaty from 1944 with some stipulations I'll talk about later. But really that's what the water in the river is, unless it's raining locally, which hadn't happened lately. So it's international. The springs are fantastic. This is one of them. This is San Rosendo, Mexican hot springs, we call it. This is on the Mexican side. Either boaters or there's actually a ranch not too far south here. Somebody stacked a bunch of rocks. There's some sequence of pools here. This is a great place to stop winter or summer. It's just a pool of fresh water that's coming out of the ground like many other places there. So that's the Mexican hot springs. This is right below one of the rapids that you have to negotiate. So you get past the rapid and you can celebrate having survived that rapid at San Rosendo. So there's a lot of problems with the Rio Grande, not just in the lower canyons. And that includes some declines in water quality. If you have reduced flow, but a salt load that's fairly constant, the TDS has gradually gone up. And we're actually listed on the 303D list with the EPA for salinity. The lower canyon springs cure that, but farther upstream and encroaching in the lower canyon is that issue with salinity. The total dissolved solids, sulfate and chloride are all part of that EPA 303D list. And that's only in the Big Bend. We're not talking about El Paso. But then there's also some other problems. There's really three main things. There's water quality. There's a decline in flow because we've stopped the Rio Grande from coming, and we've mostly stopped the conchos. So we don't have what pre-development, there used to be annual flushing cycles, monsoon rains that would just flush the river channel, clean it out. Well, we don't have that anymore. So what's happening is sediment is building up. So in this case up here, the concept is that if you don't have those flushing floods, sediment will pile up because there's a sediment load that comes from local tributaries, but some undesirable species, including Arundodonax, which is a giant river cane, which is loves an open sandbar next to a river. So it takes over and colonizes and monopolizes and drives out the riparian vegetation and turns the river that used to be this wide open meandering flooding thing into a constrained ditch. Basically, the sides are now 10 feet higher and they're silt and they're armored by Arundo, and it's hard to move it. So one of the things that has been done to experiment with trying to cure that is to burn it. So we have teams that go down both sides of the river. We have Mexican cooperators that do this, and we burn the cane for 600 meters in one section maybe, and then you wait a couple of weeks until new sprouts start coming out, and then you go in and spray that with an herbicide, trying to knock back the cane. We'll never get rid of it, but we're trying to knock it back and let some native vegetation come back. Hopefully in the future, we'll be able to tie those with some experimental or controlled releases out of Mexico. That conversation is in the works, but Mexico, Conagua has reasons to deliver water from the lower dam and the conchos, and the environment is not at the top of that list. It's mostly irrigation, but someday we may get some targeted releases to burn and spray and then get a flood to move that sediment. That's what we really like to get to happen. We can see in this graph down at the bottom, this x-axis is time from 1900 to 2020. And basically the bottom line here is relative vegetation density. So there's been an increase in vegetation basically in the riparian corridor adjacent to the river over time. And then the channel width is the top graph. Up until about 1940, it fluctuated, stayed kind of wide. But then after 1940, the width has declined thanks to the deposition of the sediment and the armoring of that sediment with the Arundodonax. This is from the thesis of Dave Dean, right here, USGS hydrologist, who's worked with us a lot on this system. So basically, you have this feedback loop. You have reduced flow, which contributes to sediment deposition, which contributes to erundo, which degrades the whole system, and they kind of feed off of each other. So if you don't have flow, you can't get rid of the sediment or the nasty plants. And if you have the nasty plants, they're going to stabilize the sediment and on. So it's kind of a feedback loop overall, in the wrong direction. That is a big problem upstream. In the lower canyons, it's starting to become a problem. We do have the springs that contribute to flow. So we have more flow down there than you do upstream in Big Bend Park. This picture is in Boquillas Canyon. And so that's Black Gap, I think. So anyway, the basic idea is the river channel is compromised because of things that we have done. And it is a problem. There are some endangered species involved here. The Rio Grande silvery minnow is one of them. It was extirpated in the 1960s, reintroduced with these numbers you can see up until about 2015 by U.S. Fish and Wildlife. They're pretty happy when the water is clean and there's a little bit of fine sediment. And there's a photograph of us searching for them in the lower canyons. Problem with the study there and with the search effort is Fish and Wildlife lost their funding for that. And so they're not looking anymore. So I am a hydrogeologist and a volcanologist, and I just know it's a little fish. So I'm not the person. So I don't know if the silvery minnow reintroduction is working or not. I would like to know that. But one thing I do know is that the Texas hornshell, which is another endangered species, is there, and it is very happy in the lower canyons. It likes fresh spring water. It likes some rocky overhanging banks. And it is definitely one of its, current locations is the lower canyons, but also up here in the Delaware that Steve talked about. Those spring-fed streams up here in Texas, New Mexico, also host the Texas hornshell. So that's one that's there. That's one whose environment is being compromised by some sediment encroachment that I'll show you here in a minute. So let's look at hydrogeology a little bit. There's the regional aquifer map. A little bit of an old one. The igneous is not like this. The igneous is now a larger single polygon instead of these three. But that doesn't really matter because we're mostly looking down here. Steve showed exactly this same thing. The general flow lines appear to be from northwest to southeast down to the springs that I'm going to be talking about. And there's clearly something going on in Mexico we don't know anything about yet, but we do hope to better understand that as we progress with our data collection out there. So we are talking about Edwards Trinity Plateau aquifer primarily for the springs that we're talking about in here. And that would be Glen Rose, Glen Rose, Del Carmen, Santa Elena. That would be the strata locally, the way we would describe it, maybe with the Maxon sandstone in between. The Glen Rose is the Trinity, the lower one, and we think most of the water's there because usually you don't see the springs unless you see the Maxon sandstone. There's a clear sandstone out there that's the structures exposed at certain locations. Usually you see the springs when you see the Maxon. The Del Carmen is above it. You usually don't see water coming out of it. So I recently had a project. We've done these seepage runs a lot of times. The most recent one was funded by the National Park Foundation. And we did a synoptic study, meaning you try to measure as many flow values as you can over a shorter period of time. You pick a time of year when it's likely not going to rain, February, 2 years ago. Tina is, I don't know if she's in here. She was on that trip. And we merge our data with data from the gauges. USGS has a gauge at Castellon. IBWC has one at Johnson Ranch, USGS at Rio Grande Village. And then we measure the blue, or what we did. And then IBWC has one over here at Foster Ranch. So what we're doing is we're looking for measuring flow in the river and associating increases or decreases to changes related to water losing, river losing to the aquifer, or aquifer coming in. And we can do that because there are no tributaries that are contributing any significant flow. We're below Terlingua Creek. We're below Alameda. There's no other tributary. So if you work out the math, there's only one reason the flow should increase, and that's because the groundwater coming in because there are no tributaries. So that's kind of part of the design. So we were able to measure at numerous locations through the lower canyons. That's the hot spot really, because that's where in the past we've seen most of the spring flow increases. So here's the results. This is really the meat of what I have to say. River mile 900 down to 650. That's miles upstream from the mouth in the Gulf of Mexico. There's Castellon, the US or IBWC gauge, USGS Johnson Ranch, IBWC, all the way down here to Foster Ranch, IBWC. So even without that, you could say, well, it was here. That's about 5 or 10 cubic feet per second in one of the North America's longest rivers. 5 CFS is not much. And then down at the bottom, the gauge is almost 250. So, but where exactly are those increases? Whoops, let's go back. Oh, right there. Rio Grande Village, if you've been to Big Bend National Park, you've been to the hot springs, they're right downstream from there. And then the entrance to Boquillas Canyon, we're up to about 70, 65 or something like that, just due to the springs in the park. Boquillas is a losing reach down to Black App, but then the big gain happens right there. That's between Black App and San Rosendo, where I showed that picture of the pond where the spring was impounded. Silver Canyon is right in there too. So we see a big jump up to 200 CFS there. And then there's a different group of springs that contribute a little bit less flow, have a little bit different chemistry that add a little bit, and then further down here to Langtree. So we're seeing an increase of 250 CFS, which equates to about 185,000 acre feet per year, if you work that math out, which is a lot. And we'll see how that relates to some other issues later. Water quality is improved at the same time. So this lower graph has the same x-axis upstream to downstream, and it's a measure in the field of specific conductivity. You probably know what that is. It is higher if there's more dissolved solids. So basically the river came in with its 5 CFS there. We didn't measure it over there, I guess, but it had about 1,600 microsiemens per centimeter at Rio Grande Village, and it declined to about 900 or so microsiemens. Take 2/3 of that, and that's approximately your total dissolved solids in milligrams per liter. So compare that to San Solomon Springs. The river started off lower because that'd be about 1,000 milligrams per liter, and it drops down to 500 or so, 400, something like that. The spring complexes are 2 groups, Las Palmas and Madison Fold. And so those springs are pretty constant in their chemistry. They're always at about 800 microsiemens or about 400, depending on which group. So we have that as a constant. The river comes in at different levels. It just depends on what's going on upstream. But regardless, almost always the river conductivity declines because it comes in with a higher level than the springs do. I did have an unusual trip a few years ago when it rained a lot. The river came in lower than the springs because it was local precipitation, and the springs actually pushed it up, which is very unusual. But that was just because of a recent precipitation event on a river that had no water in it. In terms of that kind of Piper diagram that we looked at for San Solomon Springs, we have 2 groups, and the larger group, the Las Palmas group, is in the red, and this Piper diagram has the TDS circle. So if the circle is larger, the total dissolved solids is higher. So our upper group, or upriver group, that's larger volume, plots basically right in the middle of the Piper diagram, and then the lower group, smaller circle, plots a little bit off to the left. What these are superimposed over the patterns there are the distribution of some wells that are up gradient to the northwest in Brewster County still. Some might be over in the next county, But basically, I'm going to show you in a minute a divide, a structural geologic control that trends from, and remember the flow is from the northwest. So basically, we see this chemistry difference, the two different chemical facies, if you want to call it that. We see that in wells up away from the river also, which supports the flow path direction that Steve showed, which is from the northwest. So here's a great map, maybe a little hard to see. This is a structural map, structural geologic map from SMALL, the IBWC, International Boundary and Water Commission, back, I believe, in the 60s, 70s, were really interested in dams. They wanted to impound some water, and, you know, Amistad was a result of that too. But this is the geologic map that they built in kind of preparation, you know, research for that. And what I want to show you, let's see, this location right here is Bullis Fold. Structural, it's a monocline. Basically, it's a monocline. It shows as an anticline, but it's really a monocline. It is one of many northwest-southeast trending folds and or joints that are pervasive through the whole lower canyons. So we have Bullis there. I get a little bit lost when I'm looking at this distinguishing tributaries. I think this is where Silver Canyon is. Pat Goodson can maybe help me with that. But the point I want to make with this is from Bullis, the spring chemistry upstream from Bullis has that higher TDS. The spring chemistry below Bullis, mostly over here, below Upper Madison, which is here, has that lower TDS. So one of the major structures through there is unnamed. It goes right there. It's parallel to Bullis. And I want to also say that these are part of the laramide, associated with the laramide orogeny, one of those orogenic events that has affected the Trans-Pecos. That's the one that resulted from compressional forces from the southwest, some overthrusting in the Big Bend National Park that Dr. Kelch studies. And in the lower canyons, this is kind of distal for laramide, but I believe, and Jesse might or might not, but that what I'm going to show you is a transpressional structure, a structure where compression associated with some strike slip motion allowed for some motion this way, and either the formation of that Bullis fold, or what I'm going to show you, a flower structure, which comes in those tectonic environments also. I think it's significant because it's really interesting to look at, but also it's right in the boundary between the two spring water chemistries. So I think what happens in the subsurface upstream from it, I think that the fracture patterns are better developed. There's a longer residence time in the subsurface before this comes out. And downstream, the TDS is lower, implying either a less soluble rock that it's in contact with or a shorter residence time. So I prefer the latter, but that needs more evaluation. So we're going to look at some structures along this, some photographs in the field from along that structure, immediately downstream from Rodeo Rapid, by the way. So as you float downriver, this is on my science trips. This is on one of those days between springs and we don't have much to do, but just get downriver and worry a little bit about Upper Madison. It's coming up around the corner. And so you spend a lot of time just floating and taking pictures. So we're interested in looking at this. I've referred to this as a possible flower structure. And so you can already see, I'm going to embellish with some color what I see in the field. So there's that. And then you come around the corner and then you see that. So this is what you see from the ground. If your eye is seeing things like mine does, this is what you're seeing. So a transpressional structure flower means you're pushing and material in between is being forced upward and it opens up in the upward direction. One of the thrust faults that's on Small's map is right up here to the right also. So there's some connection there. So you have these drag folds on both sides. You have east and west sides of a fault, and the strata in between has been turned vertical and it's being forced upward. To me, that's a classic flower structure. on a local scale. There's a graphic from Pat Dickerson's information she gave me that shows how your eye might want to see that. Where we have, this is my flower right there. I don't know the mechanics of it, but it tends to open up at the top. So we go right downriver from there to that flower. So structurally, there's some things going on. We've really talked about have a student get in there and work on this, but the ranch wouldn't let us have above river access. They said no. The logistics of getting a structural geological student in here when it takes 7 days just to do the whole thing. There's no springs right in this vicinity, so you'd really have to load up with water upstream. You could do it, but it would be logistically a real challenge to go spend a couple of weeks trying to map this kind of thing. Plus, this is on the Mexican side, which we'd have to get permission there, and it's all vertical. So I still want to see something happen there, but there's some challenges that are associated with trying to get a project done to study that. Okay, now, so that's the structural geology, that's the spring chemistry, and the spring flow. I want to talk to you a little bit here about the channel change and the problems that are encroaching. If upstream we burn cane and free up sediment, guess where it goes? It goes down here. So we're seeing the impact of an influx of sediment, maybe related to that or maybe just natural. But as part of that same study, I went in on a different trip and did a lot of topographic surveys. So we've been doing this for several years. So what we have here is a cross section from river left to river right. The river channel is here, and the floodplain and the adjacent sand gravel bar is on either side. This one example is at Silver Canyon there, and a picture is actually as useful as the graph, really. 2009, that whole sand cobble bar was wide open. One reason for that is 2008 was the last time we had a really big flush event. We don't get those very often, every 20 years or so. The last one was in 2008. So that sandbar had been stripped off in 2008. And then by 2024, that's the same place. So what has happened is this cobble bar that's here, that might be the same one, might not be. It doesn't really matter. The same canyon is right there. So what has happened is infrequent floods have deposited sediment, and then the vegetation gets on that. There's at least a meter of silt here in 2024 that was not there in 2009. And then you get that silt up there, and in this case, it's some woody brush vegetation, different types of plants, and at least it's not a rundo this time, but it kind of armors that. We literally landed a helicopter as part of a medical evac in there in 2011 or something like that. You'd never be able to do that today. This is on the Texas side at Silver. You'd never be able to do that today because it's choked with vegetation. The same place, there's 2012. This is where we measured discharge right at Silver. That canyon's right there. 2012, it's still pretty open, but you can see some arundo and other vegetation starting to come in. And then in 2024, that's the same picture. So it's now choked. It's got sediment, that meter or so of silt, and then a lot of mesquite and a lot of other woody brush. I can't remember which ones they are. So that's the kind of changes that happen over a 20-year period or less. The flashes that we get are not frequent enough to keep the channel open. We need another one, and statistically, we've been getting them every 20 years or so, but we're still waiting. And should we get it, then it should blow that open again, but we may not get it. I don't know what might happen. Same thing at Lower Madison. We've seen this increase in this one elevation in feet. So this is feet, 10 feet of sediment on river left over a few years. That's on this side at Lower Madison. So basically that section was just to show how dynamic. You wouldn't notice if you just went and floated once. If you floated twice, you might. But once you start looking at it over 10 or more years, you notice there's changes. It's not the way it used to be. Sometimes it's better. If we could get another 2008, that would be awesome. Because that opens up, and And, it is an environmental thing. The horn shell really prefers lack of sediment. It likes that kind of the horn shell likes this kind of rocky bank. But if you cover it with sediment, it's not going to like it. Same goes for camping. If you're with a big group or the vegetation limits the opportunities for camping, which is one thing that's important also. Okay, now let's talk about the international issues. 1944 treaty for the Colorado and the Rio Grande. We're still good. What it does, and it's a complicated thing, and I'm always saying it wrong, but bottom line is over a 5-year cycle, Mexico is obligated to deliver a total of 350,000 acre feet per year, but not in any one year, over the full cycle, through the Conchos and other tributaries that are farther downriver. So it's not just the Rio Conchos. There's some other tributaries, but the Conchos is the main one. So Mexico is supposed to deliver a total that averages out to 350,000, but there's no annual requirement. They could wait until the last minute and do it all if they had the water. So what we've learned is, I think this number, I put 150 on this one. The springs that we're measuring, I think that number is a little higher, 180,000 acre feet per year. So the spring contributions are not as much as Mexico's supposed to deliver, but are more than Mexico delivers on many of their years, like the last 4. And I'll show you graphs that show that in a minute. The agencies that are involved, IBWC and SELA, International Boundary and Water Commission, and then the Mexican equivalent, they monitor flow. They're the ones that have the gauge at Johnson Ranch. They have one below the confluence up at Presidio at the vehicle bridge. They have a gauge on Alameda and Terlingo Creek. They have one down at Foster's Weir, and then they do the Pecos and the Devils. Those are all part of their accounting. So basically, it's just accounting. Is Mexico delivered or not? How much? And then what needs to be done. CONAGUA in Mexico is the agency that controls the releases. So they're the ones we talk with about, hey, wouldn't it be great if we had some water? Let's do an experiment. That's not successful yet, but it might be in the future. So here's a graph you might have seen. It's a little busy, but it's very informative. If you haven't seen it, I want to show you what it is. This is the last 5-year cycle, which ended in October of 2025. And it shows some number of previous 5-year cycles. Doesn't really matter how many. But on the x-axis is 5 years. 1, 2, 3, 4, 5. 5-year cycle. On the y-axis is accumulated volume released in acre feet. And by the Conchos and the other tributaries. So if Mexico were able to just keep it status quo, let's stay on top of it, the releases would be right along that diagonal. That's the 5-year total right there. But you can tell that all of the previous however many cycles there are, they're all less than that, except for these weird verticals over here. And those were 2008 and maybe 10, when there's one thing that might happen if you get a 2008 style event, which was a big precip event on the Conchos. If Amistad and I think Falcon are filled, the cycle starts over prematurely before the end of 5 years. So that's what happened there, and there. In those 3 examples, Amistad filled, so they just reset the cycle. Otherwise, they're all less, sometimes significantly less, including the last one, which is this black one. So the one that ended last October, right at the end of 4 years, Mexico was way behind, farther behind than ever. But then via some negotiations, there were releases from one of the tributaries in the valley. I can't remember the name of it. And that's what those little stepwise things. They ended up getting third from last, but never reached that. The penalty is nothing. I don't believe. Somebody in here might know better. But there are many negotiations going on at the SELA, IBWC, and other levels about minutes, which are modifications of the treaty Mexico claims they don't have water. It's a drought. Well, true, but they're sure using a lot for irrigation. So there's a lot of things that need to be done. We may never see releases like this. We hope we do, but the new graph has not started yet, so I can't show you what's going on. It would just be a tiny bit of year one. But that's the story, is that the expectation is 350,000 acre feet per year. The reality is something a lot less than that. But the groundwater kind of saves the day in the lower canyons. So if you look at a graph, if I've been doing these seepage runs for 20 years and I'm not seeing declines, but that doesn't mean they're not happening, because it's really hard to do those and you can't do them every year. It's been 2 years. But from what I see, regardless of the season, regardless of the period, the position in the 5-year cycle, the springs give us that. Should my interpretation of my data that they're not declining, the springs forever give us that. We hope forever. So some years it's more than Mexico delivered in some of the 5-year cycles, including the last one. So there's more water coming out of Edwards Trinity and a few others going into Amistad that are coming into the whole system from Mexico via those 6 tributaries. To me, that's a big deal and very important. I'm having a hard time getting the science group to recognize this, but that's a different story. There's a map that's come out recently. Jack Schmidt was part of this, Samuel Solis and at UC Davis, that gives us a graphic that kind of shows the was and is, nothing to do with the treaty or anything, but the blue is the modern modeled natural flow. With the hydrology models, they can estimate what the flow was before development, and that's the blue. So the Rio Grande was as it was starting in Colorado all the way through New Mexico and then down to the Gulf. And also the Conchos blue, natural. And then the gauged flow, the current flow is the red. We've pretty much killed the Rio Grande via the Rio Grande Compact. There's hardly anything coming down below thanks to diversion, starting in Colorado and New Mexico. And then the Rio Conchos still has some flow. That's the red. There should be a difference in the width of the line right here, according to my data, but it's not on these yet. And then by the time we get to the Gulf of Mexico, there's not much. So it's a problem. It's not something that's got an easy fix. We can't just go get rid of dams, diversions and that kind of thing. But what we have to do is negotiate, and basically irrigation is the main user. So we have to talk about what is the priority and can we use the water with irrigation, but maybe more smarter. I don't know what to do. But Mexico is really kind of losing that battle in terms of they're not making their treaty deliveries, and irrigation, I think, is the main culprit. So that is the end of my presentation. That's Upper Madison. We're looking upriver. There's a couple cool things that I want to point out here. This is from a trail that you can hike. It's an old, I don't know, Ray Scholl says it was smugglers. I don't know, but there's a pretty well-developed trail you can get up on top. Beautiful view up there at Burro Bluff. The rapid itself is a big rock fall. It's pretty deep in the canyon, kind of like the rock slide in St. Helena, but bigger. On the Mexican side, there's a flat exposure of some Glen Rose limestone with dinosaur tracks in it. And on the right side, is a camp that's kind of choked with arundo now. It used to be different, but has the world's worst infestation of raccoons that you've ever seen. But yeah, one of the happy places down there for sure. At low water like that, that's when you got to get out and push your boats over the rocks. If it's cold and wet, you have to portage around. If the water's up, it's, like I said, it's sporty. It's really fun to paddle that. And by the way, the best condition to do a seepage run is when the water is low. So I try to avoid times when it's going to rain or when the water's high, because if you have the less coming in upstream and the spring flow spring flow is constant, then it's a larger part of it's a stronger part of the signal. So you measure it, it's a better way to measure. And by the way, the technology that we use is acoustic Doppler current profiler. It's a device that I set up a cableway across the river, and you carefully tow this boat that is pinging sound waves down. And with the Doppler technology, the sum of the sound waves will bounce off a sediment particle back with a Doppler shift, and it can detect a velocity out of that. So you get all these velocity cells as you move the little boat across the river. So that's the accepted better way to measure flow, as long as you have 100 CFS or so. At less flow than that, then we've got weighting rods. I don't know if some of you might be familiar with the top set rod and a velocity meter, or maybe spinning cups, or whatever. You can use the AA or a pygmy meter if it's flow with the spinning cups, or flow. Sontec makes a flow tracker which uses Doppler, but it's a fixed position velocity measurement tool. So there's a lot of really interesting technology. It's kind of the science that we geek out on lower canyon strips to use to. And I've been doing this for a long time. I feel like I really am doing it right. And I'm very careful. It takes a long time to get a good flow measurement. You first have to make the right choice of where. You have to pick a place where the flow is smooth. A rectangular concrete channel is best, but you don't find those down here. So you have to pick that spot that doesn't have boulders, no eddies coming back up. It's got to be just right. Then you rig up this cableway with a static line and get your team to help tow the boat across and stuff like that. It's rewarding. It's also very, it takes a lot of work to get any one measurement done, and it takes a lot of time to do it right. We just did this on the Pecos River also about a month ago, 3 weeks ago. The lower Pecos we put in south of Pandale at James King's property and took out at the Weir Dam right above the confluence, part of a similar study that's funded by the Bureau of Reclamation that Sweary Mauricio is coordinating out of Southwest Research Institute. But exactly the same thing, except the flow was lower. So we just use flow trackers for that. So that's it. Thank you. Not very. They're really warm springs. In the summer, they're super comfortable. In the winter, sort of. If I remember right, they're about 27 degrees centigrade. 35 is 95. They're like 75, 70, something like that. Yeah, they're comfortable, but they're not true hot springs. Yeah. Yes. February is the best time. And we missed our window this year. I was on the Pecos. The survey, that topo survey, the last one I did was in June, and it's hot. You can get in the water, but it was hot. And sometimes June is the only time I have to do it, and I have to go, but it's hot, and you risk a monsoon flash. So that may or may not be an issue. Yeah. Water loss coming down the river. Why? Oh, the loss. In Black Gap, it crosses between Boquillas and Black Gap. There's a rift structure. Black Gap has a graben structure, and I think it's related to that rift structure on the west side of Black Gap. It's weird that Boquillas has a bunch of travertine on the bottom of the river, which implies groundwater. But we've never measured any chemical change or flow difference. In fact, we've only seen a loss there. But it's probably that loss is related to the structure in Blackout. Yeah, sure. Yeah. It's low. I didn't even see it. You know, we did 3 weeks ago at James King's property, we measured 50 CFS, and then downstream we peaked at 81, and then it declined to at the end 70. That's a few miles upstream from the high bridge, 70 CFS. We did it in 2010 with a graduate student, and it was 170. And not only that, but the spring increases were higher. So the groundwater flow system that's feeding the Pecos has declined. Yes. That's a good question. Produced water, if TCEQ approves to put it in the Pecos River, um, I can't say it would not be a good idea, assuming the water quality is okay. It would be ideal if it could be introduced on a natural cycle. So there'd be a flood pulse because the fish need that recruitment opportunity for spawning and stuff. But oil and gas doesn't work that way. So it would be when it was available. But I personally, I'd say we'll take whatever we can get. Now, will that mobilize some salt and just move it downriver? James King is concerned about that. If you heard his question at Water in the Desert, I still think more is better. So my personal opinion is I would not object to it. Getting some water in that upper part of the Pecos, you know, there's interesting, the Pecos group, the lower canyons have been called the lower canyons for decades. I don't know when we first started calling them the lower canyons. And then we have a forgotten reach upstream of Presidio. But now the Pecos River has a lower canyons and a forgotten reach too. So they stole our terms. So that Pandale down is the Pecos lower, and that Cayenosa, Gervin, that's the forgotten reach of the Pecos. Iran, there's hardly any water there. And any water there would be an improvement, I think. So others may not agree with me on that, but I think that that's a good application of that produced water if it's going to be there. Sure. Yeah.
When I think of something that's gonna happen geologically, you gotta have 50, 100 feet of elevation change. I'm talking about a lot.
Yeah, it was there. I did in 2008, I did a raft trip through Boquillas. Normally it's 3 days, and I did it in 4 hours or something like that. When we got to the end, I don't know if you've been to La Linda, but there's a high bridge there. And normally you can walk out on it, you look way down to the river, or you can float under it. I touched it when I floated under it in 2008. And Pat, I don't know how many feet is that? That's up there. Yeah, 50 feet at least. And one of Jack Smith's students that I spent time in Boquillas with mapped the geomorphology, and he had flood surfaces. One, last 2 years, two, 2008, and those are pretty high up there, 34, depending on how, if it's like this, it's going to be higher. If it's more open, it's be lower. But the gauges show we were gauging the Rio Grande before we built the dams. Bureau of Reclamation put in Elephant Butte first in like 1917 and a similar one in Mexico. We have data before those were put in, and the highest flow measurement was 100,000 CFS, and 2008 had a high of about 50,000. So 2008 was a big event, but before the dams, we had one twice as big. And you can still see relic, they call it the Todd's, the master's thesis students named them FS1, flood surface 1, flood surface 2, flood surface 3. You can still find them, and they're way up there. We'll never see that with the current dam structure, unless, you know, the climate might be weird enough it could. But at least in 2008, we saw 50,000, and that was a lot of water. It was a huge amount of water, and it ripped out like not all the cane. It was like one of my friends said, I've seen infinity. There's always more Arundo. In 2008, that high event was a month long, and there was still Arundo ripping out. We just never got it all. Its abundance is infinite, apparently. Yeah, right, right.
All right, are we good? What, guys?
Hey,
Thank y'all.